True false. If I were to tell you today that we need to do this presentation 3 floors up, you would not really be happy, right? Well, okay. Well, on the south coast of South Africa, there was this tiny cold water molecule sitting and having to move up to the surface. A tragic phenomenon. An eviction translated in oceanography as the upwelling. But why was this upwelling happening? And in fact, it was actually happening throughout the whole year. So, Sherlock Holmes and Dr. Watson decided to investigate this case, and and in this presentation, I'm going to present you a bit about how they managed to attempt to solve the appalling case of Port Alfred. So, first let's go back to Port Alfred upwelling. There are other upwelling cells in the area. Each of them behaves quite differently than another. And here we have some mesoscale features which we need to understand before understanding the Port Alfred upwelling. We have this huge influx of foreigner water molecules coming in, also known as the western boundary current, our Agalus current. We're going to look at the Agalus current into two different components because each of these two behaves quite differently. In the northern component, you have a very narrow continental shelf. As it gets to the southern component, it's much wider. And in the northern component, it's a birthplace of cyclonic eddies. You get those massive eddies with huge eddy radius, known as the natal pulses, and you also get those shear edge eddies, which last about 15 days. As you get to the southern part, you also get eddies, which is fueled by vorticity, because the continental shelf is much wider there, so it causes friction with the current. So, another important feature which we need to understand is a strong northeasterly component. So, as I mentioned, Sherlock Holmes and Dr. Watson decided to investigate this case and look at model outputs of ROMs, a model which was forced by Gloris and Era 5, which was run from 1993 to 2014. And which is about 60 vertical levels, and it's a horizontal spatial resolution of 2.5 kilometers. So they decided to look at the link between current and the upwelling. And here they decided to delve into two case studies. One where actually the bottom stress and the geostrophic velocity was very high, and you can see upwelling was happening here. But on the other upwelling event, which was in March 2010, the bottom stress and the geostrophic velocity was average. So, was it current driven? Well, we also investigated the effect of cyclonic eddies. Now, cyclonic eddies on the leading edge because it's upwelling, on the trailing edge is downwelling. And here they look at two methods. They look at an algorithm to measure the minimum distance between the core of the current and Port Alfred, as well as an eddy tracker algorithm. And with that, they were able to plot a time series to identify all the big meander events, and which was pretty cool because we were able to compare that with other studies like from Marjolaine Craig and Christina Russo, where we seem to agree about 1.8 meanders per natal pulse per year. But looking into the upwelling events for April 99, while there was a cyclonic eddy happening, during the event in March 2010, there was no cyclonic eddy, and upwelling was still happening. Something important to note that the model was not able to reproduce the cyclonic eddies at the exact time when it was happening in real life. We also decided to look at the along-shore wind stress, and in this first case, April 99, there was downwelling supposed to happen because of the positive along-shore wind stress, while on the other one, it's negative wind stress in the southern hemisphere, leading to upwelling. So, comparing the Bacon upwelling index, not talking about Bacon, we compare that with model-derived vertical velocity, but we could see a gap between them. So, which means that the wind couldn't explain all the upwelling which was happening. So how do we actually denote which one might be the most important forcing mechanism for Port Alfred? Should we do a correlation method? Not really, because it can't really focus on the cold events, extreme cold events. So we decided to go for a combined EUF analysis, where we were able to reduce all the dimension of all the variables and compare whether it was current-driven or meander-induced or wind-driven upwelling. And through here, we were able to see that bottom stress and wind stress curl and wind stress were one of those leading variables. But we have to remember that the model wasn't able to reproduce the cyclonic eddies all the time at the same exact time. So this was also important to note. While each variable were able to reproduce an upwelling, but when they were combined together, they were able to reproduce a much stronger upwelling event. Thank you.